As we start the journey into trigonometry and in Algebra 2, we want to look into vocabulary of how to start looking at trigonometry using a coordinate system. So we're going to put them on the XY plane. We're going to look at how that relates to what we already know in trigonometry, and then some initial vocabulary as we work on it. So first of all, we want to use a coordinate plane here. On the coordinate plane, just a reminder that this is the x-axis, this is the y-axis, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. That's all from review from what you probably learned either in geometry or in your Algebra 1 course. Now, as we look at this, we want to do an angle in these coordinate systems. The important part is you want to start your angle. The vertex of the angle is at the origin. So standard position is vertex at the origin. Then you want to make sure that you have, when you work with this, that you start the first ray of the angle on the x-axis. So the initial side on the x-axis. So you would start it, for instance, looking like this, with your initial part of the angle, and then you would rotate it counterclockwise. Right, so we're going to take the angle and we're going to rotate it up like this. Counterclockwise is our positive direction for the angle. So if this were our angle here, our initial side here on the x-axis, initial side, and then as we rotate the angle up like this, we'll call the angle theta. So if this is our starting point, then this is called the terminal side. This is where it ends. So it rotates around. Now it could end in any of the quadrants. It could keep rotating around. We want to make sure though that as we rotate it, you go counterclockwise. Instead of, we're typically used to like a clock going this direction, you want to go into the first quadrant, then the second, then the third, etc. Now just a reminder of how these angles are listed. That would mean that if the initial side and the terminal side are both on the x-axis, that would be a 0-degree angle. So no measure if it's there. Now if we rotate the angle all the way up here, that's a 90-degree angle if our terminal side would end up on the y-axis. If we keep rotating it and we rotate this angle all the way past 90 degrees over to here, this is 180 degrees, just as a reminder. And then if you keep rotating it all the way into past the third quadrant back onto the y-axis, this would be 270 degrees. And then if we were to rotate all the way around back to the beginning, it would be 360 degrees. So this here could either be a 0-degree where we don't rotate at all, or rotate it all the way around to be 360 degrees. Now, let's go ahead and do some examples of angles on the coordinate system in standard position. So if we wanted to do 270 degrees, as we just talked about, you're going to rotate it this direction. So it's going to start here, and then it's going to rotate past 90, past 180, and all the way over to 270. So this would be my angle, 270 degrees. Now let's say that we wanted to do 120 degrees. 120 degrees, we go past 90 and we keep going. So 90 degrees, 30 more degrees would take us to 120. So this would be 120 degrees for our angle in standard position. What if we wanted to do a negative angle? A negative angle is where you start here, instead of going counterclockwise, you go clockwise. So it would end up going this way 40 degrees. That would be my negative angle. And then lastly, what if I have 480? What if it's more than 360? Well, you have to go ahead then and rotate it all the way to 360 and then keep going. 360 plus 90 would give me 450. And then if I go past it, I get to 480. Notice that this 480 goes the same amount past the y-axis as this 120. So these two here actually end in the same place. They have the same terminal side. So this one and this one have the same terminal side. Okay, so when we have that, what we want to do is we're going to give that a name. When they end in the same place, have the same terminal side, we call that coterminal. They share the same terminal side. So these would be angles with the same terminal side. So what we'll do is we'll go ahead and sometimes do problems where we find coterminal angles. So if I ask you, so for when you're doing these, the way to find a coterminal angle is to add or subtract 360 degrees. Notice if you subtract 360 from 480, you'll end up with 120. All right, so let's take a look at these two. This one here, find a positive and negative coterminal angle. So if we take 135 degrees and we add 360 to it, when we add those two, we're going to get 495 degrees. Now, that's coterminal with 135. If we take 135 and we subtract 360 degrees, we'll get negative 225 degrees. So those two are coterminal. They have the same terminal side with it. How about if we use negative 700? Now be careful with this one. Notice if I could subtract 360 to get a coterminal angle. That would be fine. There's an infinite number of coterminal angles, right? You could just keep adding multiples of 360 or subtracting multiples of 360. But notice if I take this negative 700 and I add 360 degrees to it, you then get to negative 340. It's still negative. So it's more than two rotations, or more than one rotation past the initial side, and so we could go ahead and add 360 to get to negative 340, and now we can add another 360 to that negative 340, or how about if we think of it this way, because you could do multiples, if I can take my original one and add 720 to it, 720 is 360 twice, that will end up giving me a positive 20 degrees. So there's a positive one. If you add another 360, you'll get another one. So there's an infinite number of ones for it, but we want to make sure that we capture one positive, one negative in a problem like this. All right, next let's turn to another vocabulary term. These are called reference angles. Reference angles are where you have angles that you want to have acute angles always, whatever quadrant you're in. So when we look at this, this is the acute angle formed with the x-axis. if you recall from geometry what an acute angle is between or including 0 to 90. So what we want to do is make sure that we put here that this is typically between 0 degrees and 90 degrees. Now, please recognize, I'm going to underline the x-axis because a common mistake here is finding the angle with the y-axis. So when I look at 110 degrees, notice 110 degrees here rotates all the way over here to the, let's hold off on the examples a minute. Let me show you what this looks like in some of the different quadrants. So if I were to rotate to my terminal side here in the second quadrant, notice if this were my theta angle over all the way over to there, this angle here is the angle with the x-axis. This is my reference angle. And notice I would be able to take 180, subtract that theta, and I would get that angle. So in this case, it would be 180 degrees minus theta to get that angle. Now what if I were to rotate all the way into the third quadrant? Into the third quadrant, I go past 180 degrees over here. Notice that this angle, if this is my theta, this angle here, I've got this little angle as my reference angle. It's the angle with the x-axis. So instead of taking this angle with the y, just like we didn't take this angle with the y, we want the angle with the x-axis. Well, this would be the angle itself minus 180, because you take all the way to the angle, subtract off the 180, so this would be theta minus 180 degrees to get this angle. Now, lastly, if we were to go all the way into the fourth quadrant, so we go past 180, past 270 over to here, this would be my angle. This little angle here is the angle with the x-axis. This is my reference angle. Now, to do that one, notice that I haven't gone all the way to 360, so this would be, if this is theta, if I go with 360 minus the theta, I'll get that little tiny angle there, my acute angle formed with the x-axis. So let's try a few problems here. An example would be 110 degrees. So 110 degrees, if I were to draw it here, I would go ahead and go past 90. I'd go over here. Now notice that past 90 degrees, I'm past it 20 degrees, but I'm not interested in the angle with the y-axis. I want to know this angle here with the x-axis. So what I would do is I'd take 180 degrees minus 110 degrees, and I would get a total of 70 degrees for the reference angle. This angle is 70 degrees short of getting all the way to 180 degrees. Let's try the next one. Let's try 202. So if I were to do this one, I'd go past 90, past 180, I'd go right over here. Notice that that's 22 past the 180. So this angle here, if I were to find the small acute angle here, that's going to be 202 degrees minus 180. I take off the full half circle to get just the acute angle, and 202 minus 180 would give me 22 degrees for that reference angle. All right, let's do this last one here, 305 degrees. So if I draw it past here, past 270, over here to 305, what I want to know is how far short have I come from 360? So that would be 360 degrees minus 305 would give me 55 degrees for my reference angle. Notice all of these are acute angles, and they're formed with the x-axis, not the y-axis. All right, lastly, let's do a problem here, kind of a next step problem of working with the coordinate system. We want to find all 6 trig functions using this ordered pair. If this ordered pair is on the terminal side of the angle, let's go ahead and find the rest of these sides. Well, if you go ahead and draw this one, -5 would be here, 12 would be here. This would be my ordered pair, -5, 12. It's in the second quadrant. Now, you gotta be very careful here. People tend to, as a mistake, this is a mistake, what they'll do is they'll connect these two by mistake. That forms a triangle. It is not the triangle we wanna do. So you gotta make sure that you draw it from the origin. Remember, our angles are from the origin. So this technically is what theta is, but what I'm gonna do is I'm gonna use this angle here as my reference angle. So I'm gonna draw my triangle with the x-axis. Whenever you do these, you're going to drop the side of the triangle to the x-axis, either down or bring it up. So draw the other side of the right triangle with the x-axis. Draw the side to the x-axis. It's an important step for doing these problems. Now, what I need to know is I've got sides. I'm going to draw it on the triangle. This side is equal to 12. This side is -5. Let's go ahead and figure out what our hypotenuse is here. So if you were to do the Pythagorean theorem here, you do -5 squared plus 12 squared is equal to, we'll call this h for hypotenuse, h squared. So that's going to be 25 plus 144 is equal to h squared. Now we go ahead and get 169 equals h squared. So you take the square root and you get 13. Now if you remember your Pythagorean triples, you might remember 5, 12, 13, so you might get there a little quicker. Sometimes you'll have square roots. Sometimes you'll have this not simplified to a nice integer. It might actually have a square root on the problem, which we would leave in. We'll look at some of those later. So this hypotenuse is equal to 13. Now use this reference angle, not this one up here, not the right angle. We're going to use the reference angle to find my trig functions. Even though this says theta here, you're going to use the reference angle in order to get these values. Now, to do that, what we'll do is we'll go ahead and find sine of it by looking at this and saying sine is opposite over hypotenuse. That's going to be 12 over 13. Cosecant, on the other hand, will be the reciprocal. It will be 13 over 12. So we've got those two quickly. With these sides here, cosine is the adjacent over the hypotenuse. So -5 over 13. And secant will be the reciprocal, 13 over -5. And lastly, for tangent, it's going to be the opposite over the adjacent. It will be 12 over -5. And cotangent will be the reciprocal. It'll be -5 over 12. So what we've done is we've transferred our trig problems now into a coordinate system. We draw our x-y axis. We think about where the origin is. That's where we start our angles. We start rotating. We've looked at the vocabulary of what our coterminal angles are, what our reference angles are, what an angle in standard position is. And then we've done a problem like this where we want to find all the trig functions using a coordinate, a point on the terminal side, and then we use the Pythagorean theorem and find the 6 trig functions.